Okay, fantastic pre-calc students. Today we're going to talk a little bit more about ellipses, and then we'll talk a little bit about circles. We're going to end today with completing the square, and we'll get more practice at that because a lot of the stuff we're going to be completing the square for the rest of this chapter. So we have two more sections. Um, Today I'll just do two quick problems completing the square. If you are struggling, go find YouTube videos and you will get enough practice with the next couple sections as well. Um, okay, so this is something I didn't go over that I kind of wish I did on the first day. So just to clear up any confusion, this is two different versions of um, standard form of an ellipse. We talked about x minus h and y minus k. Both those are squared, and then they're both over a denominator always equal to 1, always a plus sign in the middle. Okay. I referenced that sometimes we call these denominators a squared and b squared. When we write them like this in these two different versions, let's assume that a is greater than b. Or you could think a squared is greater than b squared, either way, right? Um, so that means that this a squared is the bigger number. And what we talked about is if the bigger number is underneath your x, that's your horizontal um, variable, it's going to be an ellipse stretched horizontally. This one would represent an ellipse that is stretched vertically. Okay. In either scenario, when we talk about the foci, which were always along the major axis. So here's my major axis. Remember, these are called vertices. My foci would be equidistant from the center along that major axis. So same thing over here. This would be my major axis. My vertices are here. By the way, these other ones are called covertices. Um, my two foci, one would be there, one would be there, somewhere in that area. But they would fall along your major axis, which is vertical in this one. Okay, because a squared we're saying is bigger is underneath y, stretched vertically. So in either scenario, the foci can be found by using this formula, c squared equals a squared minus b squared. I didn't use a squared and b squared. I said your bigger denominator minus your smaller denominator. And you'll notice that if we're claiming a squared is bigger, that's exactly what we're doing. Okay. This is not BS, I promise. Anyways, so once we find that, we would take the square root because c is the distance from center to focus, which is the plural or the singular of foci, um, along major axis. Okay, so we're going to do a couple more of these. But another thing I want to talk about, thinking of circles as ellipses. A circle is a specific type of ellipse. So we can agree that this is my standard form of a circle. Here's my HK, here's my R squared over here. Well, if I divide both sides by 16 here, you'll notice that my right side is equal to 1, and I have a plus sign here. That's my two criteria for having an ellipse. So what would I have? I would have x minus 3 squared over 16 plus y plus 4 squared over 16 is equal to 1. Where's my major axis? Well, because both these are the same, right? Which one's a squared, which one's b squared? I don't know. Um, Take your pick. It doesn't matter. They're both the same number. But what we're saying is I'm going to be stretched exactly the same vertically as I am horizontally, which, oh, by the way, that's a circle. So if these two denominators are the same, just multiply both sides by that denominator, and that'll get you to what you started with, which is our standard form of a circle. Okay, so just recognize that if your two denominators are the same, don't get confused that there is no major and no minor axis. Just know that that's a circle. You need to multiply by that denominator to get it into your circle standard form. Okay, so more challenging problems. I'm going to graph and find standard form for each of these. So the given information, center is 3, -5. I have information on the major and the minor axis, and the major axis is parallel to the y-axis. So what I always like to do is just kind of set up the structure of what your formula is going to look like. All right, I know I have two squared terms, x, y. Well, I know h and k, right? So that's x minus 3, y plus 5, okay? My major axis is 16 units, which means 8 in both directions from the center. I don't know if it's up and down or left and right, but if I'm going 8 units, that means that 8 squared, 64 over 64 is one of my denominators, right? If your minor axis is 12 units, that means it's 6 in both directions, again, either left, right, or up, down, depending on how we're stretching here. Well, if it's 6 in either direction, 6 squared is 36, so my other denominator is going to be over 36. This tells you where the bigger number goes. So if my major axis is parallel to the y-axis, well, that tells me that's parallel to the y-axis, right? That tells me it's going to be stretched vertically, which means this goes with y, this goes with x. So it would be over 64 for the y plus 5 and over 36 for the x minus 3. Okay. So I guess I didn't really need to sketch much on that one, but on this one I am going to sketch. So they tell us vertices are negative 2, 4, and negative 2, negative 2. Let's sketch those. So negative 2, 4, and negative 2, negative 2. Okay. And it passes through negative 4, 0. So I know that since these are vertices, that's a vertex, vertex, that means that this is stretched vertically. Okay, that's a terrible sketch, but that's okay. Because these are vertices, I know that since they lie up and down, that means it's going to be vertically stretched. Okay, so where's my center going to be, right? I have x something squared over something plus y something squared over something is equal to 1. Well, my vertices right in the middle there is going to be my center. So these are 6 units apart, aren't they? So I would be, center is right here, left 2 and up 1. So center of negative 2, 1. There's my h, k. So x minus negative 2 squared, y minus 1 squared equals 1. We know that the vertical is my major axis. So that is from the center, I'm 3 up and 3 down. So that tells me that 3 squared, or 9, is going to be my denominator under y because it's a vertical variable. Okay. The last thing that I need is this denominator underneath x. Well, the way I find that, I don't know anything about the distance in this direction, but what I do know is an x and a y. So we can plug those in. So when I plug in x, we get, let's see, there's x and y. So negative 4 goes here. I'm going to call this b squared down here because we said b squared was a smaller one. 0 goes in here. So negative 4 plus 2 is negative 2 squared gets me 4 over b squared equals 0 minus 1 is negative 1 squared. I'm sorry, that's not equals. It should be plus 1 over 9 equals 1. Okay, subtract 1 over 9, so that gets me 4 over b squared equals 8 over 9. And we can cross multiply here. I get 36 equals 8b squared. Divide by 8. Divide by 8. I get b squared is 36 over 8. Or if I divide everything by 4, I get 9 over 2. Do I need to find b? I don't. all I care about is b squared because my denominator here is b squared, right? So there's my b squared value. So let's put this all together. I'm going to have x plus 2 squared over 9/2 plus y minus 1 squared over 9, and that is equal to 1. Okay, we'll do one more quick one and then we'll get into completing the square. So this one's not too bad. If you have, this kind of looks like it would be an ellipse, but I don't have any denominators underneath my x and y, and I'm not equal to 1. So I can make the right side equal to 1 by just dividing by whatever you see. So dividing by 36 gets me 1, divide by 36, uh, divide by 36. 9 over 36 is 1 over 4. 4 over 36 is 1 over 9. So this is going to give me x squared, which is really x minus 0 squared, right? So x squared over 4 plus y minus 5 squared over 9 equals 1. I said plus, I wrote times. You guys got it. Okay. So completing the square. This is general form, by the way. We're going to talk about that another day, but package your x's together. So x squared plus 6x, leave a blank. Notice that these are both 1, right? The coefficient for my squared terms. Package your y's together. So plus y squared minus 20y, leave a blank. Get that 96 to the other side by subtraction. Okay. So what I want to do to complete the square, this is my first perfect square. Take half of my linear term and square it. Half of 6 is 3, squared is 9. Half my linear term is negative 10, squared is plus 100. Now, I need to offset, I need to balance the other side. I added 9, and I added 100. Okay, so this is going to give me, this is really x plus 3 squared plus y minus 10 squared is equal to 4 and 9, that gets me 13. There's no denominators here. There's no coefficient in front like I had up here. Okay. So this is just a circle, right? Negative 310 with a radius of square root of 13. All right. The harder one, I'm going to whip through this real quickly because I have about a minute and a half, and then I'll go over more problem types later in the week. Group your x's. Group your y's. Get your constant to the other side. Factor out only the leading coefficient for each variable. So I'm only going to factor out 9 here, not 9y. I'm going to leave y squared. Okay, now within the parentheses, take half of negative 8 is negative 4, squared is plus 16. Take half of positive 2, which is 1, squared, it's 1. Now, let's think about this. I wrote plus 16, but it's really being magnified by the number in front. So it's really 25 plus, or 25 times 16, which is 400. I've added a value of 400 over there. So I need to write plus 400. Over here, I've really added a value of plus 9. Okay, so that leaves me with x, 25, x, that becomes x minus 4 squared plus 9, y plus 1 squared equals, this gets me 225. Dividing by 225 will give me my answer, and you guys can check the PDF for that. All right, guys, appreciate it.